So in this example, we're going to create a web page that has pretty much the same behavior as the pages that we've looked at previously in this section, but with no lines of code at all. Essentially what we're going to do is create a version of products-web3.aspx. This is a finished version if you want to go directly to see what the final result is. All right, so I'm going to come here to Website, select Add New Item. I'm going to select a web form, and in this case I'll call it just Products. The language that we select makes no difference whatsoever. We're not even going to create a separate code file because the end result is going to have absolutely no server-side code within it whatsoever. I'll even go so far as to delete this entry there, as well as the script block that was created. We're just going to have absolutely no code within the page. All right, I'll go over to Design View. And now we need to add a control that will take care of getting the data from the database. So I'll go to the toolbox, close the Standard section, open up the Data section, and double-click on the SQL data source to add that to the page. This is an invisible control at runtime, so notice that it just has the gray box format on the page. Next thing I need to do is configure the data source. Essentially, I need to tell it where this data is going to come from. So the first step in the wizard is to choose the data connection. We could create a new connection, or we can select the SQL connection from the drop-down list. The reason that this option is there is that the SQL connection string is defined within the web.config. So the configure data source wizard is smart enough to look at any available connection strings. If we want to see what the actual connection string is, we can click on the button there and we can see the full connection string. Make sure that it's the one that we want. All right, I'll click Next. At this point, the wizard has gone out to the database that was defined within the connection string and now has a list of the available tables and views. So we need to tell it where it's going to get its data. This is for the drop-down list for the categories, so I'm going to select the categories table. And then I also need to specify which fields I need to return. If I wanted all the fields, I could select this checkbox here for the asterisk, and that'll essentially do a select star from categories. But in this case, I don't need the description and picture, so I'm just going to select the category ID and the category name. Notice that as I make selections, it builds the select statement right in front of me, so I can make sure that everything is going as I want it to. I also want to sort the data, so I'll click the Order By, and I'll sort by the category name. Notice that all 4 fields of the table are within the list. I can sort on any field, even if I'm not returning that field from the database. But in this case, I want to sort by category name, and it needs to be ascending. I'll click on OK, and Next. At this point, I could click Finish, or I can test the query. It'll actually go out, read the data from the database, and I can make sure that I got the data that I wanted. Looks like I have all the categories, looks like they're sorted, everything's great, so I'll click on Finish. So let's take a look at what the designer did for us in the source code. Here's my SQL data source element. Has a default ID of SQL data source 1. It's a server-side control, so it run at server. Here it has the connection string, which it's reading from the collection of connection strings that are available to this project. And then it defines the select statement, select category ID, category name, from categories, order by category name. Obviously nothing that you couldn't type in yourself, but it just makes it a little bit easier to have all of the choices presented to you within the wizard format. Now we have a data source. We know where the data is going to come from and what form it's going to take. I'll go back over to Design View and continue to design the form. We want to add a list, so I'll drag a drop-down list over to the form. We want to create a version of the page where the products are returned automatically when the user selects an item from the category list, so I'll enable the Auto Postback property there. Yet another way to set that property on a control on the form. I need to choose the data source. Notice that it's currently unbound. I already have a data source defined on the page, the SQL Data Source 1, so I'll go ahead and select that. I want to display the category name, so that's what's going to actually appear to the user in the list, and then I'll use the category ID field as the value that is returned when the user makes a selection from the field. Click on OK, and notice that the text here has changed to data bound because it is now tied to the SQL Data Source control. Now we need to create a data source for the products table after the user makes a selection in order to display the data. So I'll go here and view the Server Explorer. Server Explorer is a handy window that gives you access to various services on the web server. So I have data connections, and then I have various things that I can access on the server. Current server is called User01, and so we can access various resources on that server. I'll right-click on Data Connections, and I will add a connection. And so what I'm going to do is create a new connection to the database. I'll select the server name, User01, and I actually want the SQL Express instance. So I'll go ahead and type that in. Then I can select the Northwind database, test the connection, and we've defined a new data connection. Now in reality, I already had that connection defined, so it just reuses that same connection because it sees that it's the same definition. Now I can drill down into that connection and see various objects of that database. So I have tables, and I'm going to drag the products table onto the form. Now as you can see, it's added another SQL data source, I'll hide that there, another SQL data source along with a grid view to display the data. So keep in mind, all I did was drag the products table over from the Server Explorer. Notice that the data source is already set to the SQL Data Source 2, which was added as part of that operation of dragging over the table. Now I want to configure the data source a little bit because by default it's bringing over the entire contents of the table, all of the columns and all of the rows. So I'll configure the data source. And this is the same wizard as we saw just a little while ago. It's going to use the Northwind connection string 1. I'll click on Next. And then I can deselect any fields that I don't want to include from the products table. So in this case, all I want are the product ID, product name. Get rid of these. I want the units in stock, but not the other ones. So now we're going to be returning much less data from that table, fewer fields. I still want to order by the product name in ascending order. And I also want to specify a where clause. Remember, this is a table that is going to display the products for a particular category that the user selects. So we need to filter the results. We want to filter on the category ID. We want to use the equalities operator because we want to match a particular category ID. And we want the source of the value to come from a control that is on the page. Because what we're going to do is we're going to use the value that is returned from the drop-down list control in order to populate the list. So this is the value, this is the source of the value that is going to be used within the where clause of that SQL statement. I'll click Add and OK. So now you can see that we have a where clause where the category ID is equal to a parameter that is passed in at category ID, and behind the scenes we've defined that the source of that parameter is going to be whatever the user selected within the drop-down list control. Select Next. I can test the query. It prompts me to enter a value. I'll enter a value of 1. Click on OK, and I can see that it returns values, and yeah, that pretty much looks like the beverages. So we're in good shape. So I'll click on Finish, and now we've configured this SQL data source. So now Visual Studio has seen that we've changed the fields in the SQL data source, and it's just asking, do we want to clear the grid view columns and data keys in order to refresh the fields? And I most certainly do, because we're not going to get a lot of those fields from the database anymore. And notice that I have the 3 fields that I selected. I also want to make absolute sure that the grid at runtime displays all the correct fields. So I'm going to go to the task list for the grid view itself, edit the columns, and specify that I want to auto-generate the fields. I'm not going to specify any fixed fields. I'll save the changes. And then I'll display this page in the browser. And as you can see, we get the same basic results. The one difference is that when the page initially loads, there is already a category selected. In previous versions of the page, we just displayed a blank page. But in this case, the grid view and the data controls see that there is a selection within the category, picks up the category ID, and goes ahead and displays the data. So it's a little bit different behavior, but it kind of makes sense. There's something displayed there, so we should show the products. Okay, so creating this page took a few steps. There were kind of a lot of clicks as we went through the wizard and so forth, but they were pretty simple steps and we were prompted the entire way. And there is no code within this page whatsoever. Now, in a production application, you may want to write your own data access code and to segregate it into separate business objects. And there are other objects, such as the object data source, that supports that kind of scenario. Still makes it pretty simple, although you're going to write some business objects behind the scenes. So Microsoft has really made a major effort to reduce the amount of infrastructure code that you have to write over and over and over again. When I saw some of these features initially, I was a little concerned that they were trying to work me out of a job. But as a practical matter, what the net effect is that a lot of the infrastructure code that is part of every application that you're likely to write, particularly if it uses data, is now taken care of for you. And you can spend your time on writing all of the interesting code for a custom application. And that's really what programming is all about. Over the years, Microsoft has worked really hard to make Visual Studio the premier web development tool. In fact, the premier tool for developing any kind of Windows applications. It really has a dizzying array of features that you can take advantage of for your applications. It's almost unending, and I can't claim that I've used or am familiar with every single one of them. It's just there are so many features and tools that are built into the user interface. And what's most interesting, too, is that there are very often many ways to do the same sorts of things as well. So in this section, we're going to cover a few of the development issues that you need to be aware of as you develop various kinds of ASP.NET applications using Visual Studio that can really save you a lot of time. One of the issues is code behind versus inline code. The idea here is that Visual Studio and ASP.NET support two different models for how it integrates server-side code into an ASPX page, code behind and inline. And what this really boils down to is where is the server-side .NET code located. When you add a new web form to a web project, the Add New Item dialog box contains an option to place code in a separate file. And when you first install Visual Studio, that's checked by default. So when you select that option, Visual Studio creates two files for you. Default.aspx, or whatever name you give it, but with the .aspx extension, as well as a code file called default.aspx. An extension for whatever language that you're using, typical CS or VB. This code file is called code behind because the .NET code that runs on the server to generate the page and respond to events is in a separate code file sort of behind the page. You don't see the code within the .aspx page. So this provides a nice clean separation of the design of the page and the code that works behind it. And Visual Studio takes care of hooking up the code to the proper elements on the page for you. On the other hand, if you uncheck that option in the Add New Item dialog box, Visual Studio creates a single file called by default default.aspx and includes a script block in the ASPX file. And this is called inline code because the code is in line with the HTML. Now this is a whole lot better situation than ASP files because the code isn't really in line with the HTML. It just means that the code is included in the page. So you don't have that kind of nasty alternating code in HTML that you see in ASP files. So the page directive identifies the language used in the page, whether the code is inline or behind. Now the selection of putting code behind or inline is largely a personal choice, and Visual Studio supports you either way. And this is actually a new feature. By default, and well, it was actually pretty hard to use inline code in older versions of Visual Studio, but Visual Studio 2008 makes it easy to use either model. In general, code behind is usually a better choice for large web applications though, because it lets you take advantage of partial classes and code reuse a lot more easily. Now pretty much all of the samples used in this course use the code behind model. It's really no better or worse than inline code, but it's the default in Visual Studio, and the model that we're really most comfortable with. Another issue with using Visual Studio to develop applications is involved with the plethora of ways of creating new web projects. So depending upon the version of Visual Studio that you're using and the number of add-ons that you've installed, you may have many ways to start a new web project. Among all the choices are really two primary choices, and the chances are pretty good that most of the time you're going to use one of these two types of projects. The first is a website project, and this is a project that is essentially file-based. The other is a web application project that is probably a little bit more similar to how you think of a project if you've used other Windows development tools. You can develop pretty much any kind of website that you want to create using either project type. But the big difference is how they are structured within Visual Studio. You just get different things when you select the different project types. So let's take a look at how that works. A website project is a file-based structure with no solution or project file to keep track of all of the files or components that are included in the project. In essence, if a file is in the root folder or a subfolder of the subdirectory of the website, it's part of the website, whether you want it to be or not. So this project type was actually introduced in Visual Studio 2005 to provide flexibility for an application that's deployed to a web server as a set of files and folders. So to create it, I just come to File, New, and Website, select ASP.NET Website, put it in a convenient location, and then click OK. So here you can see in Solution Explorer the result of creating that. Notice that I don't have a project file, but it's just identified by a particular location on the hard drive. There's no separate project file that is containing all of these objects. I get an app data folder in case I want to have data as part of this, my default web form, and then a web.config file that holds configuration information. If I want to open an existing website, I would just come over here to File, Open, and select Website, and then I can navigate to wherever the folder is on my local hard drive for the website. Now the interesting thing about this is if I open an existing site using a folder, it really doesn't matter if there's any web files in that directory or not. Visual Studio will happily open the site and list the available files and folders in Solution Explorer. The one thing it does do, however, is it will create a web.config file in that folder if it didn't already exist. So it's pretty easy to convert any folder into a website. Now the nice thing about this kind of project is that it makes it incredibly easy to create copies of the site or to move it or to deploy it. You just copy this folder to your web server, wherever it's going to end up going. Or you can copy it to another directory and build a new site that just has a few differences from this existing site. So overall, this is a pretty great way to develop a web project, but it does have a few drawbacks. Because there's no container file that identifies which files are actually within this project, if I want to get rid of something, I can't just deselect it from the project. I actually have to delete it from the folder. So as a result of some of those kinds of issues with website applications, not long after Visual Studio 2005 was introduced, Microsoft introduced an add-on web application project. And with the web application project, there's a separate project file that binds everything together. So this gives you a lot more control over the project, particularly if your development team uses source code control. In order to create a web application project, I'll go ahead and start another instance of Visual Studio, and then come up to File, New, Project, and then I can select an ASP.NET web application. I can give it a particular name. I'll just leave it the default name there. Put it in a location wherever it makes sense for this. And I can specify whether or not I want a directory for the solution. And in this case, I'll leave that checked, and it's going to create a directory called Web Application 1 as a subfolder of the projects directory. In this case now, we have a little bit more complex a project here. We have a references folder that holds a number of references. There's basically just a different way of adding references to a web application project. We still have the application data directory, we have the default.aspx, the web.config, but we also have a properties directory that has some additional files for keeping track of the assembly that is generated as part of this project. There's a different compilation model for these two projects. I won't go into the details here because it's pretty arcane, but if you really start using these different projects, you may want to explore how the compilation model differs between these different projects. From a single developer's perspective, if I'm working alone developing a website, probably the biggest difference between website and web application projects is that the web application seems to have more configuration options in Visual Studio. The big way that you can see the difference is by right-clicking on the project name, selecting Properties, and you get these really nice property pages as part of the project. So you have application build, build events, settings, reference paths, all different kinds of pages where you can set various options. The big difference here is that there is a separate project file, in this case called Web Application 1, where these settings can be stored, in addition to the web.config file. But as I mentioned earlier, from an application standpoint, you can develop the same kind of websites using either project type. Now, most of the sample applications in this course are website projects, precisely because of their main feature, simplicity. It's easy to add new files to this type of project, and we don't need to use source control or build applications in big teams. So it just made sense to stick with websites for this course. When you run pages in Visual Studio, in other words, you view in browser or hit F5 to debug pages, you may have noticed a bubble that appears in the notification area, as well as an icon. You may or may not actually see the bubble. Some versions of Windows seem to suppress it, but you will have an icon in the notification area within Windows. That area is sometimes incorrectly called the system tray, but it's officially called by Microsoft the notification area. And that looks like that bubble on the right-hand side of the screen. And what it does is it provides the protocol, the server name, in this case localhost, a port number, and the application name of the application that you're viewing through Visual Studio. What this means when this icon and bubble appears is that the page is running under the ASP.NET Development Server, not under Internet Information Services, which is the Windows web server technology. So using the development server greatly simplifies web development by eliminating the need to use IIS or even have IIS installed on your development machine. This is particularly nice if you're running Visual Studio on a version of Windows that doesn't even include IIS, such as the home editions of some of the Windows versions. The issue is that when you run projects under IIS, you have to create a virtual directory. Now, Visual Studio in most cases will take care of that. If a virtual directory doesn't yet exist, it can create it. And then Visual Studio hands off control to the virtual directory within IIS. Now, this can really cause problems if you're not an administrator on your local machine, because creating a virtual directory is a privileged operation, as well as slowing things down. It takes a little bit of time in order to create that directory. Now, the development server is an application, not a Windows service. It is not a full-blown web server. It's not a replacement for running IIS. Among many things that IIS has that the development server doesn't is rich security and scalability. It also doesn't have other services such as SMTP for sending emails. With the ASP.NET Development Server, Visual Studio can create any directory folder on the file system as a website without the overhead of creating a virtual directory. And this applies to both website and web application type projects. The development server is a convenience. It just makes it easier to develop and run applications in Visual Studio. Pages rendered under the development server should appear and behave exactly the same as they do under IIS, as long as you're not using any IIS-specific services, again, such as SMTP. One other issue is that the server runs with the same security context as the user who is running Visual Studio. So that means if your website requires a specific security context, such as the anonymous user or another user, then you may have to use IIS. Another thing to be careful of is that the development server uses ports other than port 80. It uses 4 or 5-digit port numbers, relatively high numbers. If you do anything in your application that depends on communicating over port 80, then you should use IIS. But as a practical matter, it's a bad practice to build such a port dependency into an application, so this really shouldn't be a problem very often. So let's see how this works. You can configure the development server within Visual Studio by selecting the project name in Solution Explorer and opening the Properties window. So here I have a website open, and here's the properties, and I have a couple properties that I can set to control the development server. The first one is the Use Dynamic Ports property. This is true by default, and what it means is that each time the development server starts, it randomly selects an available port, and it's usually in the higher range, 4 or 5 digits long. So if I set that to false, the port number property is enabled, and I can specify a specific port number. I'll set that back to true. That's not really a feature that you probably need to use very often. The other option is Always Start When Debugging. This property controls whether the server starts even when the website is not the startup project. This should normally be set to true, but really comes into play when you have additional projects that are not web projects within the solution that is currently open. Now, if you want to use IIS instead of the development server, the project has to be a web application rather than a website. So using IIS is not an option with this particular project because it's a website. So I'll go over to a web application project, select the web application, and right off the bat, I have fewer options. The only option that I have within the Properties window is to always start debugging. I have no control over the port number. But in order to specify to use IIS when I run this project from within Visual Studio, I right-click on the project, select Properties, go to the Web tab, and scroll down to the bottom where I have this option of Use IIS Web Server. And so now when I start this project, either by pressing F5 to start with debugging or right-click a page and view in browser, it's going to go to IIS, have IIS serve up the page. If it needs to create a virtual directory, Visual Studio still takes care of that and does all that nice stuff. The nice thing is that Visual Studio will still do all the heavy lifting of configuring everything for you, so you just have to run the project. One of the problems in developing applications with earlier versions of Visual Studio is that a particular version of Visual Studio was tightly bound to a particular version of the .NET Framework and Common Language Runtime. So that meant that if you ran Visual Studio 2002, it only worked with .NET 1.0. Visual Studio 2003 only with .NET 1.1, and Visual Studio 2005 with only .NET 2.0. There were some kind of lame workarounds if you absolutely had to open an older project in a newer version of Visual Studio, but they were pretty lame and pretty unsatisfactory. But the nice thing is that you can open older projects in Visual Studio and continue to work on them using the tools in Visual Studio even though you're compiling against an earlier version of the .NET Framework. This means that you can develop applications using any version of the .NET Framework since 2.0. Unfortunately, you can't use it for version 1.0 and 1.1 because there were some pretty substantial physical changes in the Common Language Runtime that made that a pretty onerous task for Microsoft. But the nice thing is that you can open older projects and continue to work on them using the tools in Visual Studio even though you're compiling against an earlier version of the .NET Framework. And the nice thing is you no longer have to upgrade all of your projects when a new version of Visual Studio is released. Multi-targeting support comes into play when you create a new project. In this case, I'll create a new web application project, and I get the New Project dialog box, and here you can see the multi-targeting support. By default, Visual Studio wants you to develop using the latest version of the .NET Framework, but you can also select Framework 3.0 and 2.0. Notice that when I select 2.0, the number of templates decreases. The reason is that some of those other templates use features that weren't supported in version 2.0 of the framework. All right, I'll go ahead and create a web application project. And now I have a project that targets .NET Framework 2.0. One of the places you see a difference is if I right-click on References and add a reference, I get the Add Reference dialog. If I scroll down to the .NET Assemblies, you can see that a number are grayed out. They're disabled. I can't add them to this project because those are version 3.5 and 3.0 of the .NET Framework. That's not supported by a .NET 2.0 application. So Visual Studio does the right thing and keeps me from adding any components that I can't use within this project.